Hi, I'll go over how to do Lab 9 of ECE 285, which is regarding second order RLC circuits. So for this lab, we have a series RLC circuit where we have an AC source, and we have a 1K resistor, 1 microfarad capacitor, and 1 millihenry inductor. And what we'll do in lab is we'll just measure a frequency sweep across the resistor, because we want to measure the max voltage across the resistor. So what we'll do is connect. So using this, we won't be necessarily be able to measure the max voltage, but we can measure the resonant frequency, and that's where the max voltage would occur. So when we use the network analyzer, we won't see the max voltage, but we'll see the decibels. So what we could do is once we determine the max voltage, at what frequency the max decibel occurs, we can switch over to the network analyzer, or sorry, not network analyzer, the signal generator, and measure the actual voltage. So here, let's do this. So we'll go to the network analyzer. So this plot is in dB. So that's why we can't necessarily measure the voltage, because the dB is just a relationship between the input and output and input voltage. But what we'll do is we'll go to the 3 parallel lines on the top right, and then make sure we set our start and stop at the right volt frequency. So it's 100 hertz to 1 mega. And then what we have to do is we have to measure the input voltage drop. That will be our reference. So with my circuit, I have my channel 1 measuring across that input voltage. My input voltage is coming from this yellow wire that's connected to a green. So it's going from from the green wire to ground. And here's my 1 microfarad capacitor, 1 millihenry inductor, and I'm using a 3K resistor. So there will be slight difference from my results compared to your results. And then I don't necessarily need this red wire, so I'm just going to put it off to the side. So channel 1 is measuring across that input. Channel 2 is measuring across just that resistor, because that's what we need. So I'll switch over to here, and then go ahead and click single. We need a input of 5 volts. So I have set the amplitude as 10 volts, which is 10 volts peak to peak. So it will be 5 volts peak. So give it a moment to gather the data. Okay, now that the data is done collecting, what we need to do is look at both of these plots. So if we had the frequency sweep in voltage, we would be we could easily just measure the max voltage across the resistor. But since we have a Bode plot, which gives us magnitude and phase, which you'll learn more in 286, for right now, what you just need to do is scroll using decursors. You enable them by clicking the blue box to the left of cursor on the bottom right of the screen. So once you do that, you scroll until you find the the maximum decibel value. So if I keep scrolling, you see how the the maximum I see is about negative 0.04, but it's for a great range of frequencies. So that's not very preferred. So that's where we'll look at the angle. So we'll keep going until the phase is as close to 0 as possible. Oh, I missed that. There we go. So that's as close to 0 as possible. But if you look at the magnitude, it's still negative 0.04, but we've narrowed down at what frequency the resonance occurs. And it's at that voltage, or sorry, at that frequency. So it's about 4.56 kilohertz. And that is what I should be getting anyway for my theoretical. So what I'll do is, to measure that voltage drop, I'll input 4.56 kilohertz into my signal generator and then use my oscilloscope. So I'll switch this to kilo, and then switch this to 4.6. Oh, forgot to press enter. 4.6 kilohertz. There we go. Beautiful. And then I'll just switch this to 10. Then go ahead and click run. And then now I'll just open up my oscilloscope, click single. Okay, need to shorten this time base by a good bit. Then go ahead and click run. And then tweak with these some more, so that way the whole graph is measured. Okay. So now when I look at it, you see how the input voltage is roughly the same as the voltage measured across the resistor, and that's essentially what's supposed to happen. There's a slight change because there will be a tiny voltage drop across the inductor and capacitor, but most, if not all, of the supplied voltage is being dropped across that resistor at the resonant frequency. And that is how you will do experiment 9 for, lab 9 for ECE 285. Good luck.